Hey everyone, this is Stacy with SF Johnson Consulting and Construction Services. And in this video, I would like to go over material quantities. You know, a cost estimate is one thing, but once you win, you have to be able to produce the material quantities or the quantity of material you need for your scope of work. And in this video, we're going to look at it for concrete and all of the elements related to our concrete foundation. A couple of things you need to think about. And so this is an AutoZone foundation, and let me just identify some of the things that we're looking at. So we have a full section view of the foundation. And then we have detail views, and these are detail marker, section view marker. And so these are the things that are going to tell you what the foundation footing configuration is made out of. And so what do we need for our concrete foundation? We need our rebar, we need our formwork, and the amount of concrete. So if you are a concrete contractor, this is one of the things we show you in our concrete and masonry estimating modules, where we give you increasingly harder foundations to build the estimates for, help you with the three-step process. First step is the takeoff, from which will help us with the material quantities. So anytime we're looking and we're doing the takeoff, you should always be performing your material quantities as well, so you can pretty much kill two birds with one stone. So if you're into concrete, if you're into construction, if you're a general contractor, if you're a project manager, make sure you subscribe, join, hit the like and bell notifications so you can be notified when I put some new information here or have something that's very valuable that you may want to purchase for yourself or for your organization. This is Stacy Johnson. I've been doing this now for 14 years. Prior to this, I was 10 years a construction defect litigation adjuster, and I enjoy helping my contractors. All right, so three things we want to concentrate on material quantities. First, let's look at the formwork. Well, you're going to have formwork for the footings, and so it's going to be the thickness of the formwork. So we have a 5-inch thick concrete slab. And so we've got to be thinking our formwork is 5 inches thick in some kind of way. And then if you have a good cost book, you're going to be able to determine your formwork from your cost book. Let me go and sign in. So we do have a concrete. And if you are a client or a student, you get access to this for life. So I'm just going to put in formwork because, you know, estimators have to have the right tools. Let's see how this isn't the best. There we go. Let's see what we got. Yeah, so our cost book is going to give us, so if we have column pads, it's going to give us the cost for the, see it says here, hand excavated poured against earth. So where there is no formwork in that case. So here we have a hand excavated poured against forms. And so for a 3x3 by 16 inch pad, and it gives us a typical configuration for that size. But if we find in our specifications or in the plans that it has more or less, all you have to do is add that in addition to your cost. Okay, so a good cost book is going to help you with the formwork. Press the port against forms, and so here it gives you the cost for that, for the formwork, and it's for each column pad. So tools are vital. Okay, so what do we need? So that's going to help us. So we need to know how many linear feet. So takeoff tool is vital, right? A good one. So let's set the scale. And we're going to figure out how we need to. So we're going to say our footing and we just keep all of the, although any what would be classified as an opening. And here we don't really have, we just have a continuous footer with this little piece right here, but we're going to look at that section view, detail view, to see what that's made out of. So let's do our concrete first, just for our slab on grade. How many cubic yards of concrete for our slab on grade? And this is typically how I do it. Well, we know that it is 5 inches. Okay, so we're going to change that inches into feet by dividing by 12. Of course, I don't have my calculator or anything with me. That's stupid. Okay, so we're going to tell you how to do it. And again, this is just a sample for our module. This one won't be in the module, but let me just put it in your head, because if you're doing this, you probably already know how to do it, or you have a concrete calculator, but you want to be able to put this in your head. And so first off, we're going to just figure out what our area is, and we're going to pretend that it's a 6-inch. Makes it easy for us. All right, so we have just about 7,500 square feet of concrete. Okay, so concrete, we always need that 3 dimensions, right? So the area is 2, the thickness is the third. And so just say, for instance, it's a 6-inch instead of 5-inch. So if it's a 6-inch, we change that 6-inch into feet. So basically it would divide that 7,500 square feet in half. So we'd have half of that, but that would be cubic feet. And you divide that by 27, and then you have how many cubic yards. So that's how many cubic yards of your slab on grade. And we have to figure out how many cubic yards for our continuous footer. Now, we have different section views are designed, and I'm going to look at that one too, designed to show us how walls are built differently. And so we're going to assume because we have D16 and A13. What's the majority of the continuous footer? It looks like it's different in every step of the way. So yeah, we have to look at all of the different. Yeah, we'll do A16. That seems to be okay. Well, let's just do one side at a time. Gotta tell the difference. What's the difference between F1A and A13? So let's go to, I'm gonna write that down, F1A and A13, because this is going this way, this is going that way. Okay, so we're gonna assume from this point on, from that point on, it's going to be our F1A till it gives us something else. Okay. A16 or A13? FA. Okay. Okay, so we have F1A, S5.1, and then A13. That seems to be S5.1. All right, so let's go 5.1. F1A. F1A. Okay. Okay. So this is the part of the continuous footer that's connected to a CMU wall. Okay, so this is a good place to start. So and that's the thing with our foundation. So let's take this off of there, because we have to be able to break our foundation off into the sections, and then we go to that section view, and that helps us determine the configuration of what we're looking at. So what I'm going to do first off is I'm going to break the full foundation F1A over S. I'm going to try to figure out, and we said we're going to see that's going that way down, so we're going to start it pretty much just right here. Because it doesn't change that whole, but where it does change is here, and that's just for the door. And then we're going to do that one, A13. Over S. Okay, so we're just going to continue it here. And that's for this right there. And we're going to stop that. We're going to stop that right here. I'm not sure what that's doing. I'm not sure what that's doing. I'm not sure what this is doing. Let me go to D16 and see if it tells me what it is. D16. Didn't I say D16? Oh, wrong one. Yeah, no. D16 S5.1. Maybe I wasn't looking at the right thing. D16, right? D is in dog. 16. Here we go. Now let's see. CMU. But I don't see where it stops and where it begins. So, see how this can be a pain in the butt? So I'm going to go with the ones I'm sure about. Okay. So this is for just this section right here. Probably refers to some structural component for the wall. And the same with this one, just right here, but this applies down the whole stretch, and that's A16. Okay, and that's for that. That's for the door, and all of these are the same for the door. That's for that. But here, I'm gonna go with that A16 over S. 5.1. Okay. So that's for that. See, that's D16 going that way. So it looks like a break right there. I'm going to go with that break. Yeah, that's the same. A16. And then this is just going to tell me how the step down is at the door entrance or whatever that is. And yeah, that's the door. And then where did I break it over here? I think we're gonna leave it there. And is that the same thing? D16. What do we got? Okay, D16. We got a D16 and we're going to break it off right here and go up there. D16 over S 5.1. All right, so we're going to start that from here. We're going through everything. All right, now this, I'm a little confused. A13. I'm going to take that up to maybe there. And this right here is its own thing. So I'm going to take that one to there, really. Yeah, and I'll take that one up to there. And that's something different right there. All right. And so we're just gonna measure all at the doors because they're all the same. Maybe something we need. D13. Okay, so we already did slab on grade, cubic yards. I always do cubic feet divide by 27. That gives you cubic yards. All right, so I don't know that we'll need these, but that's what that is. D13, yep, see all the indents. But see, what I really do need to do is go look at that call out. It's a call out for that, but I'm still gonna measure it. And see all the door step downs are, in case there's something special about that I need. And this is probably shear wall information. Oh, it's right there. Okay, and so number 4, 16-inch off center each way. So basically what you do is, so number 4 rebar, 16 inches. Might as well do that. These are the control joints, so yeah, you have to physically measure those. And so for the rebar, to be able to do that math in your head, we have, so this is 114 linear feet. Oh, 100, let's get accurate. 115 feet. We have to put the rebar, and then let's do this one. That's let's just say 66 feet. So if we calculate this rebar to go in that direction, we have to, every 16 inches, if I can get there. Right? Yeah. So every 16 inches. But the length is how many placements? The number of placements, 16 inches, see all the way down. But the number of placements is change this many feet, 116 feet times 12, change it into inches. That changes it into inches. And then you divide by 16. That tells you how many times you have to place it. And then that many times that length times 66 feet is the rebar just for that distance. And so the rebar for this distance, because it goes each way at the 16, right? And so we do the same thing. 66 feet times 12 inches is so many inches. Divide by 16. That's the number of placements. And then those number of placements now times that length. 115. And that's the amount of number 4 rebar just for the slab on grade. Okay, so now we'll go and look at a couple of the section views. So we have F1A. So we're going to do material quantities for both the concrete and whatever we see at the section view. So now you have material quantities for the slab on grade and for the number 4 rebar for the slab on grade. I will go to each one of the section views. F1A, we have A13, A16, and what other one? D16. Oh, that's the doors. Okay, over, and what page is it? S5.1. So now let's go back. So this is what I'm going to teach you in the module, but we'll do small stuff, then we'll work our way all the way up to larger stuff. This is more like I don't know, for AutoZone, because it's from the ground up. It would probably more like project number 3. Project number 3 or 4. And then number 4 is always a multi-story something. Alright, so I'm going to look at F as in Frank, 1A. That's this one, to do material quantities all the way up. Not for the CMU block. Just for the rebar and for the concrete footer for the CMU wall. Alright, so doesn't give us the size of this. There must be, there's gotta be a size. Is it? It's not to scale. That's terrible. See how here we get a size. So we can do any of these. We need a size. You have to have a size like that. It must be F1A must be on some type of schedule or something where it tells us what it is. Let's see. I don't know. Well, that's you got to know how big that is. Let's see if we can find it. That's this one. Let's see. See if G1 over S3.1 tells us what it is. Let's see, something's got to tell us. That's 2 feet. From here to here, it's 2 feet. Oh, that's the footer. It's 2 by 2, probably. That's usually how it works. A 2 by 2 continuous footer. One end to the other end. This dotted represents the concrete. So, but let's still go look at G1 over S3.1. Where is it? G1. Oh, okay. That's just the building section view. And this is it's probably 2 by 2. Let's see. Okay. Didn't we already go there? Yeah. D16 over S5. Yeah, we already went there. Okay. So, I mean, you can do concrete block wall. I mean, if this is the scale, yeah, it is. Then you can measure a height of your concrete block wall and the length of it. So you have your square footage of your concrete block. It looks like it is like 3-4 feet. It's typical 3.5 feet. Let's see. Because you have your stem wall, right? And that's where we build our structural stuff on. This has a little one. That's a bigger one. That's a window, most likely. Or CMU behind. Okay. All right. So let's see what that is. Yeah, about 3. I give it 3 and 4 inches. All right. So that's probably like a 2x2. So if it's 2x2 times the length, then you would have that. And our length of that F1A, we had 157 feet. And so if it's a 2x2 block, that's your 2 dimensions, that's 4. And then by the length, 116, well, that's your cubic feet. Divide by 27. That's how many cubic yards of concrete that you need for that little F1A stretch. And now let's go back to the rebar section and this is pretty easy. So just like the slab on grade is at the 16th, but this is number 5 at the 16th along the full length. What's the full length? That 116 feet. Whatever we measured as F1A, which was 157 feet. So we change 157 feet, right, into inches, divide by 16, and that's how often you'd have to place those number 5 dowels. That's how many placements, and it looks like it's 2 of them together. Okay, so that's pretty much how you do that. Pretty simple. Okay, so same here, same situation. This is a A13, our A13 section. Start from the bottom, work our way up. Okay, so we have 7 number 5s, continuous top and bottom. 1, 2, 3, 4, 5, 6, 7. So that's 14 times the length of A13, which was 17 feet. So 14 times 17 would be how many linear feet of number 5 just for this and just for that section. Okay, and then we have number 3 ties at the 8 inches off center. Okay, so that's this. Okay, so now we have to change that. How many feet? What was 17 feet? 17 feet now. Change that into inches. So 17 times 12 is that. And now you're dividing by 8 inches instead of 16, right? Because you're placing those ties at the 8 inches along that linear stretch. Okay. And everything, same thing applies all the way up. On this, the slab, we already got the slab handled. But at this, where we have our A13 section, okay, we have to add these additional 2 number 4s. So it's 17 feet times 2. That's how much additional number 4 for that. And then whatever else is pointing to. Now, we'll do this separately for the wall when we do the wall on its own. Okay, so that's how you do that. It's pretty simple. That's material quantity. So your formwork is going to be the thickness of your, because you got to form it out. So it's going to be the thickness. The depth, not the thickness, the depth of whatever you're forming out. Okay, but get you a good cost book. And yeah, it's just that simple. If you're forming walls, your plywood's got to be the area of the wall that you're one side of the wall you're forming. And you're forming footings, well, the width or the depth of that wood has to match up, and then we have to have bracing. Blowouts are nice when you don't brace it. Once it's YouTube, it's nice to watch. Okay, D13, same similar thing. Now we have to put number 4s, and it's not even telling us at the what, but okay, so that's how you do that. Just change your feet in all cases to inches. Determine how many placements or how many times you place that rebar. Make sure you're measuring the full length of what you have to measure, and it makes it pretty simple. Okay, so we're going to have a material quantities for each of the trays. Now this is just for what we just did, a foundation. Okay, and concrete, turning, getting the cubic yards together. So we have to do the same thing for, A-plan framing. How many studs do we need? We'll do that. For the masonry walls, how many bricks you need? If you know the size of your wall and the size of your bricks, you can price it by brick, by square foot, or by linear foot. And remember, the estimating modules that we have, we give you the full 3-step process, what sheets to look at, how to navigate through the plan views, section views, the detail views. Very important, so you are able to make a proper material quantities. Remember, this was all about material quantities. Your cost estimate in material quantities is going to be different, although the cost of your materials is incorporated in your material quantities in your cost estimate, because you use those quantities to determine your estimate. So yeah, you should be covered. So make sure you let me know what you think about this. Make sure to subscribe, to join, to purchase a module. You'll get lifelong training and access to the most valuable cost book in the world. So you'll know how to make a very tight estimate, how to price it correctly, how to time it right, and keep your staff working. That, I hear, is very important. So this is where I'm going to leave it. And I'm going to leave you listening to Jane Street. Have a good rest of the day. Look for more very soon.